Hey, how are you? I'm doing great. Thanks for asking. I'm just going to pre-warn you. We're going to do 2 pages of notes today because there's a lot. It's mostly a lot because I want to make sure that I have all of the definitions and stuff on the page. So that way people who are skipping these videos still get the information. Because some of you just write down my notes and move on and then are confused later. So not you, because obviously you're watching this. But maybe your friends and classmates. Those hooligans, they need to watch these. I'm not really mad about it. It's fine. But it is going to be 2 pages. It might be 1.5 pages, but it's going to be, no, it'll be 2 pages. So don't get overwhelmed or stressed out. Like, take a break in the middle, go get a snack, nap for a little bit. I don't care. But let's just jump right in so that way you're not so worried about time. So first of all, this whole page is going to be talking about end behavior. Now, end behavior, most people think is just the end of the graph, like the right side, but it's actually also the left side. It's the ends. We just call it end behavior. So let me write down a couple definitions here. All right. So the graph, how it starts is based on the degree, and how it ends is based on the lead coefficient. So let me just really quick walk us through what a degree and a lead coefficient are, and then we can talk about it. So the degree is the highest power. We've talked about this already. So the degree is the highest power. And what we care about for the degree is whether it's an even degree or an odd degree. Those are my 2 options. For the lead coefficient, that is the number in front of the highest power. Or the degree, I should say. Hold on, let me get my white out. Fixed it. Okay, we care about the lead coefficient being positive or negative. We don't actually care what the actual number is. I just care if it's positive or negative in order to graph this. So these graphs are curvy. They go whoop, or they go whoop, whoop, whoop. They do crazy things. And I kind of shown you that last time on Desmos, but I'm going to show you some more today. So if it's an even degree, it's going to start the same as it ends. I should have paused for the writing. I'm so sorry. And then for the odd degree, it starts the opposite of how it ends. So we actually need to know how it ends first before we can tell how it starts. So if it's positive, it ends going up, and if it's negative, it ends going down. Are you confused yet? I hope not, but let's talk about it. Okay, so for example, if I have the graph x 7x to the 4th plus 11 plus x squared. Let me get some colors. I don't watch sports, but I heard the Seahawks did badly, so we're gonna give them some mojo. Okay, so actually I'm gonna show you everything. So the degree is the highest power. The highest power here is 4. So it is gonna start the same as it ends because that's even. And then my lead coefficient is that number in front, which is 7. That's positive. So I have positive lead coefficient, even degree. My degree is even. My lead coefficient is positive. Okay. So what that means is that my graph is going to, I'm going to sketch it. I don't know anything else about it. But it's going to start going up, blue. Sorry, it's going to end going up, and it's going to start the same. It's going to start the same. So my graph's going to go like that. Now, one other thing that's kind of useful to know, but not necessary, like, I'm not going to test you on this, is that it has a 4th power. It's going to have 3 turns in it, which means that I'm going to go like maybe down, up, down, up. So 1 turn, 2 turn, 3 turn, power is 4. But at 7 turns, the power would be 8. So that's an important little bit there, is that it turns less than that. We can do another one if you want. It's probably fine. I might do some more examples in in like a separate notebook, but we'll see what happens. Okay, so now I'm going to define some things for you about infinity, which is going to sound crazy, I promise. It's going to sound crazy, but I promise it's not. We'll get through it together. Okay, so here's my little graph. Ew. Ugh. Look at that curvy line. Okay, so here's my graph. Let's say that I have an even, well, let's say I have a positive lead coefficient. So my graph ends up. Just like this one does. So it ends up. I don't care what the rest of it looks like, but at the end it goes upwards. So here's what I would say. I would say that as x goes to the right, which is positive infinity, the function goes up to positive infinity. So this means to the right, and this means up. I could also have, what if I had a negative lead coefficient? My graph would go down after everything, right? Here's this version of it. I would say that as x is still going to the right, but the graph is going down. F of x goes to negative infinity. So this is to the right, but this says down. How can I tell it's not right, or it's not like up and left or something? It's because x tells me left and right, and f of x or y tells me up and down, because this is x and this is y. So if it ends up, this is what I say, and if it ends down, this is what I say. So this graph says as x goes to positive infinity, f of x goes to positive infinity. Let's do the other side. If it starts up, it would be based on, I should show you the color. It's based on the degree, because if the degree is even, it would be the same. So either up, up, or down, down. And if it was odd, it would be the opposite. So if it starts up as x goes to negative infinity, that means left, f of x goes up. Left and up. Do you want to try the last one? I don't know if you're going to try it. Pause it if you are. This one is if it starts down. That's as x goes to negative infinity to the left, f of x goes down, negative infinity. So this means left, and this means down. Oop, down. I fixed it. It looks like done. Oh, dang. I'm gonna fix it. Hold on. Y'all, somebody needs to make me like matte whiteout because it doesn't, these don't write on it very well in whiteout. So I don't know how the rest of the function goes, but it's going to go and maybe it ends up. Right? So I don't know about the rest, but that's what I know. Why did I teach you this? TBH is because there's a multiple choice question on the test about this. But what I'm actually trying to do is I'm trying to show you the math version of saying left, or sorry, it starts up and ends down, or starts down and ends up, or starts up and ends up, or starts down and ends down. There's 4 total options here. Wait, I don't know, 4-ish. I think there's 4. Oh yeah, 1, 2, 3, 4. Okay. Actually, maybe I can fit this on this page. No. Yeah. Hold up. Let me talk to myself about this. Okay, we're gonna try to do this on 1 page, so that way maybe you'll forgive me for lying to you earlier. Thought I was gonna do this on 2 pages. Okay, so we want, pause this so you can write it. We want to sketch this polynomial with these specific things in mind. We want the function to be increasing to the left of 0 and to the right of 4. And we want it to be decreasing between those 2 things. This should sound familiar as we did it before, but we only did it with quadratic, so it was either down and then up or up and then down. This is going to be down and then up and then down, or up and then down and then up. Also, we want the graph to be above the x-axis between -2 and 3 and to the right of 5. And then we want it to be below the x-axis the other times. Now, this part right here tells us the x-intercepts. because what's happening is it's going to tell us that it has to hit the x-axis at -2. Sorry, I mixed up on this one. -2, 3, and 5, because it's either below or above otherwise. So on my little sketch over here, I don't know any y-axis numbers. I don't know any of them. But I know that there will be an x-intercept at -2, an x-intercept at 3, and an x-intercept at 5. I know those things are true because it has to be 1, 2, 3, 4, 5. Great. So I don't know anything else about the y-axis, but I do know that those have to be the points where it switches. Now, the other thing that I know is that there's kind of like axes of symmetry at 0 and at 4. I say kind of because they're not really axes of symmetry, but it is the highest point and the lowest point, so you can keep that information kind of in your brain if you want to. But basically, that's a point where it's going to switch from being positive to negative. Yellow was a terrible decision. Hold on. Now, we can't call them axes of symmetry because it's not symmetric, but they do exist. So let's talk about the rest of this now. It's going to be increasing until it gets to 0. So my graph's going to go up until it gets to 0. And then at 4, it's going to go up again. So then in the middle here, it's got to go down, but it has to hit through that 3 and then come down here. So basically, these tell me my max or my min are these ones. Now, I'll write that on the side just for you. Now, it doesn't tell me the actual max or min because this could be 3,000 or it could be 4. This could be any number on the y-axis. This could be the same thing with negatives. And it's not even going to be the exact same thing. And then again, this isn't really symmetric, but it kind of, like if I ignore the rest of the graph, it kind of is. And same thing over here. But so it's not really an axis of symmetry, but if you want to use that vocab, I'm okay with it. So this one, let's just practice our end behavior vocabulary, right? I know that this would be as x goes to negative infinity, the function will go to negative infinity. And as x goes to positive infinity, f of x goes to positive infinity, right? Starts, this opposite as it ends, and it ends up. So this is a positive lead coefficient, and it would be an even degree. In fact, we actually know what the degree would be because I have 2 humps, so it has a degree of 3, right? 1, 2, add 1, that's the degree. That's the part that I wanted to kind of write down on the other page, but I think we're good with just doing it verbally. You're going to practice this a ton, hopefully a ton. I have to make a Desmos activity because your book doesn't really do these kinds of things that we do on the tests. So I wanted to make sure you're prepared. Practice harder than you play. Also, we're getting kind of close to it. We have 4 sections in Unit 5 and 2 in Unit 6, and then it's finals time. So hope that doesn't scare you. Hope it just makes it okay for you. All right. I still kept this under 15 minutes. I'm proud of myself. Have a beautiful day. And we will get to one more day of factoring next time. Goodbye.